Good morning, students. Today we are going to see the continuation of Unit 3 and the second subdivision of Unit 3, supervised learning techniques, linear regression, logistic regression, and decision trees. With some chemical engineering example, we are going to discuss about supervised learning techniques. Supervised learning techniques involves training a model using a labeled dataset, which means each training example is paired with an output label. So is a labeled data. So that's what we have seen in the last class. Supervised learning involves the labeled data. The labeled data, the input and the output are correlated. The model learns the relationship between the input and output and make prediction on due data. So the model will learn the relationship between the input and output of the particular data and make prediction on due data. Coming to the supervised learning, there are different types of algorithms which has been followed in the supervised learning. Okay, so the linear regression algorithm, logistic regression, decision trees, random forest, support vector machine, and near k-means. Okay, and then naive Bayes. So we have seen elaborately the random forest and the support vector machine with the suitable chemical engineering problem in the last class. So today we are going to explain. I am going to explain about linear regression, logistic regression, and decision tree. Okay, how these three categories has been with the example of chemical engineering examples of these three categories, which we are going to discuss in today's class. So linear regression. So it is will be in the form of y is equal to mx plus c format. So predict continuous values. Okay, example house prices. So that's what we have seen in the last class also. So it's linearly correlated. Okay, so for example, the yield has been correlated with the pressure and temperature. Okay, as the pressure and temperature increases, the yield increases. So it's a linearly correlated. Logistic regression, binary classification. Okay, so for example, yes or no. Okay, that type. Okay, that is a logistic regression. So decision tree is coming is like a flow chart. It contains the classification and as well as the regression. So we will see these three different algorithms. Okay, with the suitable chemical engineering examples. So linear regression used for predicting a continuous output. How it works? Fits a straight line through data points that best fit predict the output variable. For example, here you see the yield. The yield depend on the temperature and pressure. That's what I told. So y is equal to mx plus c format. So a is the coefficient. Okay, x is the variable temperature and y is the another variable is pressure. So they have the coefficient of a and b. Okay, plus c. So the yield is equal to a into temperature plus b into pressure plus c. So here the input variable and the output variable has been correlated, and the model knows the structured label data. Okay, and this model algorithm will help you to try to understand the relationship for the new data as well. Okay, so the general concept is linear regression assumes a linear relationship between the independent variables and dependent variables. It best fits a line. Okay, best fit line using an equation of the form output is equal to a1 x1 plus a2 x2 plus dot 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 up to an xn plus b. Okay, so is a y is equal to ms plus c format. Coming to the linear regression, predicting a continuous value based on the input variables. So the chemical engineering example here, the input is temperature and pressure, output is reaction yield. When you say the correlation, as temperature increases, the yield may increase due to faster reaction rate. So how it has been correlated? Okay, so when the temperature varies, what will happen to my reaction yield? Okay, as the temperature increases, the yield may increase due to faster reaction rate up to an optimum. Okay, so pressure may shift the equilibrium, affecting the yield as per the Lee-Chatelier principle. So these both variables are linearly correlated. Okay, linear relationship. And coming to the next example, to output variable is a heat transfer coefficient. Let's say the input variables are flow velocity. Okay, the flow rate. Okay, so flow velocity, I mean the flow velocity is in meter per second, the velocity of the flow. Okay, the pipe diameter d and the fluid properties. So how it has been correlated with the output variable of heat transfer coefficient. that is very important. How what is a linear relationship? Okay, so how it is correlated, we will see in the next slide. This is a crucial for heat exchanger design. Okay, so when you see here the features, how the temperature, pressure, concentration varies the affect the yield. The first example. So temperature may, if we increase or decrease, okay, the output effect on output may can increase or decrease yield. Okay, so may increase reaction efficiency as the pressure increases. Okay, it's a linear positive correlation. Okay, the previous one is a positive as well as negative linear correlation. Okay, and the concentration affect the physical properties. So often that leads to a what you call linear relationship. Okay, and coming to the linear regression, the another example, predicting the viscosity of the polymer solution. The input variables are temperature, polymer concentration, molecular weight. So how this has been correlated to the viscosity? Output variable is viscosity. So when the temperature increases, what will happen to my viscosity? Whether it will increase or decrease, obviously the viscosity will decrease as the temperature increases. Okay, so the polymer concentration. So as the polymer concentration increases, obviously viscosity may increase. The molecular weight increases, viscosity will increase as well. Okay, so optimize the process parameters in a polymerization reactor. So it's a linear relationship. So this is a very good example for linear regression. And coming to the logistic regression, used for classification problems, binary or multi-class. How it works? Models the probability that an input belongs to a particular class using the logistic function. Okay, S-shaped curve. Okay, for example, in the chemical engineering example they have given here is predicting whether a reactor will be safe or not. Yes or no, based on the operating condition. Okay, how it has been operated. For example, as the temperature is more, obviously there will be the reaction, whether the reactor is efficient, I mean the reactor is safe to use or not, or when the pressure increases, what will happen to the reactor. Okay, obviously we have internal pressure and the external pressure we need to consider. Okay, there may be if the material which has been used for the design of the reactor could not able to withstand, what will happen? Obviously if the export pressure is inside the pressure vessel or any reactor is higher, obviously any if the material could not able to withstand, obviously it may leads to blasting effect, or the external pressure is more, okay, when compared to the internal pressure, obviously the buckling effect may take place. So these are the parameters, the temperature, pressure and concentration are the parameters which will help you to know whether the reactor is safe or not. Okay, it's a logistic regression, is a binary type, yes or no type. Okay, coming to the classification of data into categories, yes or no, that is coming under logistic regression, as I told you just now. Whether it's a safe or unsafe, okay, is true or false, anything you can take. Okay, sir, either two binary format. Okay, so predicting the reactor safety as the input, the temperature, pressure, concentration varies, what will happen to my reactor condition output. Okay, whether it's a safe is considered to be 1, unsafe is considered to be 0. For a real-time monitoring of safety limits, that's why it has been used for this logistic regression. So the correlation as the temperature and pressure increases, the reactor may become unsafe. As I told you, the pressure increases, there may be chances of blasting if the material of the reactor does not able to withstand that pressure. Okay, so you might have heard about the last incident which has been happened underneath the ocean when they use the what you called submarine. Okay, when they go underneath the earth, seashore, underneath the ocean. Okay, so they could not able to bear the material could not able to bear the pressure because of the when they delve into the very depth of the ocean. Okay, so obviously buckling because of buckling, the people who are traveled inside the submarine were collapsed. Okay, so this story you might have heard about it. So the pressure is a very important parameter. Okay, whether how much material, how much pressure that material could be able to withstand, that need to be calculated. So in the chemical engineering perspective, this logistic regression is maybe easy. You can see anywhere. Okay, so this is one of the type actually the logistic regression coming under the supervised learning. Okay, so high concentration of the reactive species can increase the assault potential. Okay, and coming to the second type example, classify waste treatment methods. The input or the chemical nature. Okay, so whether is hazardous in nature, or what you call them, whether the toxicity level of the chemical is all depends. Okay, so the chemical nature, that is considered as the input, whether is pH and biodegradability, and output is the treatment method. So whether the biodegradability or the chemical nature is very toxic in nature, okay, whether we need to go for treatment or not. Okay, it's a physical, whether we need to go for physical treatment or chemical. Obviously this type of non-degradable compounds or toxic compounds are not supposed to let it out to the environment as such. So we need to go, definitely we go for a treatment method, that whether we need to go for a simple physical method or biological method, okay, which are usually find to be a complex in nature to understand the behavior of the microorganisms which has been used in order to treat the wastewater or any sense, yeah, wastewater here. Okay, because they are just saying the wastewater treatment methods. Okay, and use they automate the environmental compliance. Okay, the purpose is to make sure that the wastewater which has been letting out to the environment is safe. Okay, so when you see here, based on the input, whether we can make sure whether it is necessary to go for a treatment method of physical nature only, physical treatment, or biological treatment. Okay, so obviously we can say actually the physical treatment as a chemical treatment or biological treatment. So physical treatment is like adding a pH, temperature variation. Okay, this is a physical method. The chemical method, biological method, aeration tank, microorganism has been involved. Okay, so that type of thing is a biological process. Even the people say physical method or chemical method or physicochemical method or chemical, even only the chemical method. So the chemical method are like, for example, penton reagent, adding a advanced oxidation, coming under the advanced oxidation process, they will add a ferrous sulfate and hydrogen peroxide as a compound in order to degrade the compounds which is not easily degradable. Okay, so we understood. So these all basic began the chemical engineering principles, but how this has been given to the system, okay, how the data will help you to identify the things whether it's needed or not based on the input variable. That's what I would like to highlight over here. Coming to the logistic regression, the another example, classify a chemical batch as pass or fail based on the quality matrix. So the input variables are pH, concentration of key compounds, temperature profile. What is the output? Okay, binary classification. Okay, it's a pass or fail. So predict product quality. The purpose is predict product quality in batch processing for early rejection or correction. Okay, so when you see input variable, the pH, concentration of key compound, and temperature profile, based on that, okay, we can say is whether it's pass the thing testing or fail the test. Okay, so obviously you can find it out. Okay, predict the product quality in batch processing for early rejection. So easily we can reject the things. Okay, this compound is not as a good quality. Obviously when this has been given as a input to the system, obviously this will be affected. Okay, classify the chemical batch as pass or fail. Okay, so even after the reaction also we can test this pH, concentration of the temperature, whether this batch has been suitable for or not. For example, I can say yeah, for raw material for a paint. Okay, when I went for an internship for Sipcat in 2003, okay, they have manufactured the raw material for the paint, pentaerythritol. Okay, so that compound they will test actually before they go for packaging, because the quality of the raw material for the paint is supposed to be good quality. Otherwise what will happen when the people try to manufacture the paint, will obviously will be reflected. If the quality of the raw material is not good, obviously that will be reflected in the output of the after the process, after next process. Okay, so they will test the characteristic of the raw material of the paint. So if that particular product is not with the standard quality, obviously we can nullify or we can reject the thing. So that's what they are doing here. So the input variable is pH, concentration of key compounds, temperature profile. Okay, that will help you to make sure that the chemical batch has pass or fail based on the quality matrix. Okay, so hope you understood this logistic regression. The third part is a decision tree. Okay, so decision tree is used for both regression as well as classification. So the linear regression and the logistic regression, the linear regression is for a regression type, and logistic regression, okay, is a classification type. Whereas the decision tree, both regression and classification is both the type we can use it. How it works? Split the data set into branches based on the featured values until it reaches a decision. Chemical engineering example, designing a decision system to determine the bits separation technique like distillation or extraction based on the boiling point difference, miscibility and cost. The chemical engineering example is designing a decision system, okay, to determine the best separation technique. For example, I want to make sure whether I need to go for a distillation or extraction based on the boiling point difference or miscibility and cost. Okay, I will tell you with an example here. So when you see here, when the boiling point difference is greater than 30%, then I can go for a distillation. If the components are immiscible, okay, then I can go for a extraction. So here is a flow chart type. Okay, yes or no. Okay, for example, I just want to. I've been working as a reviewer for many journals. Okay, so when you see here, when the people say yes or no, the editor will say yes, then it will go to the reviewer. When the reviewer says yes, obviously it will go to the next level. That means to the author, it will go with the acceptance. If the reviewer says no, again it will go back to the editor. The editor will give an commands to the author. Okay, it's like a flow charting option. Okay, so the flow chart like structure. So in that case, so if the boiling point difference is not greater than 30 degree, is less than 30 degree, so what is the decision supposed to be taken? Okay, if the components are immiscible, okay, then we can go for extraction. Okay, so the correlation, how it has been correlated, you could be able to see here. The input is boiling point difference, component miscibility. So if it is greater than 30, distillation. If it is not greater than 30, obviously we can go for some other separation technique. Okay, so if it is immiscible, then we can go for an extraction. If it is miscible, then we need to go for any other different type of separation technique. Okay, so is a flow charting option. Okay, so hope you understood how the decision trees works. Automates the selection of most efficient separation process. Fault diagnosis in a process plan. So the input are sensor readings. The output is a type of fault. So the sensor readings will help you. For example, you are getting a pressure sensor. From the pressure sensor, you are just getting a pressure value, pressure reading, and a flow sensor will help you to get a flow rate. Okay, and temperature sensor will help you to obtain a temperature of the particular region or particular spot. Okay, so the output is type of fault. So we can understand how the whether there is a leak happened or over pressure or there is a blockage or something. We could be able to find it as a output. How to find it out? The correlation are a pressure drop and open wall likely leak. Okay, so when there is a pressure drop, obviously what that will be leak. The temperature rise or closed wall may indicate the blockage. So when this correlation happens, when this nature happens, obviously that leads to the output of leak and blockage. Okay, pressure drop and open wall happens, it will lead to a likely a leak. If the temperature rise and closed wall happens, okay, may indicate a blockage. So quick identification of faults for maintenance action. Okay, so we also have seen in the previous classes regarding the predictive maintenance. Okay, so here by algorithm, by showing the input variable, we can able to input data, we can find out the output. These are all coming under the linear regression, logistic regression, decision tree, all coming under the supervised learning. So the supervised learning having a label data, that the label data, the input is equal to the input variable is correlated to the output variable. That's what I would like to say. And coming to the another example for decision tree, the fault diagnosis in a distillation column. So you know already what the distillation column, how it looks like. You have a number of trays and the feed location will be there. At the bottom you have a reboiler will be there, and at the top you have a condenser and the reflex will be happen. Okay, L by D. Okay, so when you have an input variable like say reflex ratio, the reflex ratio is equal to L by D, the top bottom temperature. So obviously in a column the top and bottom temperature will be vary because the reboiler will be kept at the bottom. So obviously at the top the temperature will be lower when compared to the bottom. Okay, and then the pressure whether it has been maintained throughout the column is same or it may be varying or something. Okay, so usually they will constant pressure system will be there. So okay, so the pressure will be maintained throughout the length of the column. The flow rate, so how much is the flow rate which has been coming through the feed location. Okay, so the output is a type of fault, whether the tray flooding or feed composition change, that is the target. So provide interpretable rules for plant operators to take quick decision. Okay, so this decision tree will help you to try to find out the type of fault. Okay, the tray flooding or feed composition based on the input variable, that is the reflux ratio and top bottom temperature, pressure and flow rate. So the input variables when is lower, for example, the top bottom temperature is getting lower, there may be chances of flooding. Okay, so that's how we need to take a decision. Okay, the decision will be decision. I mean, we can find it on the output, the target. Okay, so with this, I just would like to conclude this supervised learning. I just would like to conclude, wind up the thing what has been covered so far. So in the supervised learning, we have a different algorithms. So under which we have a linear regression, okay, logistic regression, as well as the decision tree. So we have seen all examples for or minimum three examples for all these three. Okay, that means linear regression, logistic regression, and decision tree with the chemical engineering background. Okay, so when we need to go for linear regression, when the have input variable has been correlated positively, and then logistic regression, obviously yes or no type, where you will find it out. Okay, say is a safe or not safe, or whether we need to go for a, okay, what do you call the treatment method, okay, biological treatment or chemical treatment. Whereas in the decision tree, we have a structured what do you call the flowchart structure type, where you can find it out. Okay, when this is larger, we can go for this decision. When it is lower or when this is compatible, then we will go for this decision. Okay, is that both, it contains both the classification as well as the regression. So with this note, I just would like to conclude today's section. Okay, we will see with the unsupervised learning with more chemical engineering examples. Okay, so if you have any doubt or any class, anything you would like to discuss, we can always meet on Wednesday 8th hour, where you can clarify your doubts. Okay, so meanwhile, I request you to please submit the assignment. For assignment 3 is already uploaded today. Okay, the deadline has been given for you until 20th of this month. So I kindly request you to submit the assignment on time. Okay, as well as please try to cover this material so far, which has been covered under the machine learning as well as the supervised learning. Okay, so with this note, I just conclude my today's section. See you in next class.